Welcome, ladies and gentlemen, to Warwick Science's Year 9 Film Practicals, this time on electrical components. Now, we're doing electricity in this particular unit, so one of the things that we need to know is we need to know the electrical appliance and we need to know how to connect up circuits. So today's one is going to be looking at the various different electrical appliances we have. And obviously the first thing we have here is what we call a battery, which is made up of multiple cells, and obviously these are your standard 6-volt batteries. They've got the two electrodes at the top there to be able to get the power out. This one most people know as a globe. However, when we talk about it in electricity, we talk about it being a lamp. So they are actually a lamp, and again, to be able to connect it, you put your two conductors, which are your two wires, into those ones there. This is an interesting bit of kit here. This one is a resistor, and a resistor is simply anything that stops electricity from flowing through it. And as you can see here, it's made up of just a coil of wire around, and you've got a resistance here, and this one is 20 ohms, and ohms is the measure of resistance. But basically what happens is when the electricity goes through, there is a force, this resistance force, that actually stops it from travelling, so actually less come out the other way. A lot of resistors in our electrical appliances that we've got. This one here, this one is what we call a rheostat, or a variable resistor, and you can see here that it's got the wire. It's got 3 connection points, one here, one there, and one here, and essentially how much wire you have between where your first electrode comes in here and your last one determines the amount of resistance. This is very high resistance here, because what happens is the electricity comes through, goes through this black handle here, and then travels all the way through there up to here. But of course you can move it along, and therefore what happens is the electricity comes through here, down and through the wire. So less wire, less resistance. And this is basically a light dimmer switch, and how sound works on your phone and the like. This particular one is the one that we probably hate the most, and this is the bell. An electric bell plugs in and obviously just rings. This one here is what we call a switch, and this one is an open switch at the moment, and basically in order for electricity to run through we need to close it, so we need to press it down. And again we have our two conductors here for the electricity to pass through. So that's an open switch, no electricity. That's a closed switch and electricity. Then we have just these, which are just our basic wires, and our wires are simply conductors. They're simply copper wire, and they allow the electricity to be able to move through. And then we have two measuring devices. This one here is called an ammeter, and you can see that because it's got an A there, and it measures amps that run through a particular circuit. So you always connect these ones up in series. And one that looks very similar is a voltmeter, and a voltmeter simply has a V placed there, and this measures voltage, so how much voltage is across a particular component. So you actually place these ones in parallel. So those are the basics that we basically use, and in order for a circuit to happen, a circuit must be a closed system. So for a circuit to happen, now always we need a battery, and we need a switch, and in this case we're going to basically have a globe. So when we connect circuits up, we always go from the negative, because electricity flows from the negative. We put it into the switch. The switch then goes to any sort of appliance, and in this case we've got ourselves a globe, and then from the globe we go right the way back to the battery. And what I can do here is I can actually trace where the electricity flows. So it flows all the way through there and then flows back to the battery. So that's what we call a circuit. At the moment this is an open circuit, no electricity is flowing through it, but if I was to put the switch down, we now have a closed circuit, because you can see the electricity is being lit. So open circuit, no electricity. closed circuit electricity. So that's essentially how you connect up a very simple circuit with the various components. And it doesn't matter really what components you put in, they will all pretty much work if the circuit allows electricity to move through. Thank you very much for accessing Warwick Science's Film Practical on electrical components and circuits.